Hello, today I'll show about destructive and constructive interference of the signal. So, what is destructive and constructive interference of signal? It's just nothing but you are adding a two signals. Suppose you have two different sinusoidal signal. I mean, yeah, maybe same signal with the same frequency and same amplitude with a different phase. If the phase is changed, then if you add that two different signal, what is the resultant? So whether it is constructive or destructive, I am going to show that. So suppose here tx and another end rx is the receiver. So you are transmitting the one signal with the same frequency and the same amplitude, and our receiver job is it's receiving the signal. So when it is receiving signal, it's getting the direct signal, and maybe you'll get the some reflected signal because of weather, and this environmental will cause to reflection of that signal. You'll receive with the time delay of the signal also. Maybe if you get the little bit delay of the signals means the phase will be changed. Suppose here you received one signal and with the phase 0. If you, it's a small example, if you receive the other signal with the phase 180, what is going to be happen, I will show you. Suppose I generated one signal with the phase 0 in Python, and I will show that Python code also. This is one signal, and this is the other signal. It's a signal 2. It is represented in blue color with 180-degree phase signal. So when you plot on the same axis, you can see that red color is signal 1 and blue color signal is signal 2 with the phase difference 180-degree. If you observe at that time t 0 instant, it have some positive amplitude and it have the some negative amplitude at the same time instant. So when you add the signal, resultant will be the 0. Suppose here in mathematically, sine 2 pi plus 180 is nothing but a minus sine 2 pi ft. So now your 0 phase, 180 phase, amplitude is will become the same amplitude with the negative amplitude. So frequency also same. So and one more thing you can say here, it received the second signal with half cycle delay. If you receive the second signal with half cycle delay, what it is going to be represent, this is what it is going to represent. The constructive of the if you add these two signals, the resultant will be 0. So this is what destructive interference. Suppose if you add the signal with the same phase, here signal 1 with phase phi 1 and signal 2 with phi 2, both are having the same phase, 0-degree phase. That's why you're not able to see we are not able to show you in different, like both signals are there in this. When we adding the both signal, a sine 2 pi ft plus a sine 2 pi ft, because phi is 0 for two signals, the resultant is will be look like this. Amplitude is become the double. If you observe here amplitude is minus 10 to plus 10, and if you observe here, each signal have the amplitude is plus 5 to minus 5. Two signals have the amplitude plus 5 to minus 5 within the same phase. When receiver received, it's going to be added, so it become the plus 10 minus 10. If the receiver have the 180-degree phase shift, the resultant will be the 0. See, if observe here, it is 0. See, you observe here plus 5 to minus 5, this amplitude. Even you are going to add, the resultant is 0. This is destructive interference. When it is same phase, when you are adding, it is become the double. This is called constructive interference. Video we take in the same code. If you see here, pi 2 is 3.14. Now it is going to be show it destructive interference. We added the both signal with out of phase. Here pi is 3.141592. We converted this 180-degree into radians. I will show the how to convert to radians also. Now we added a pi is 0 radians. Now let's see the resultant of the signal. uh, yeah, we are adding the both signal with both phases are same. Now if you observe the both signal, the resultant is constructive. Let's see. Yeah, if you see here, plus 10 to minus 10 amplitude, both are added, amplitude is become the double. This is what constructive interference. I will show you that conversion, 180 degrees to radians convert, phase to degrees to radians conversion. As we seen in Python code, I am going to show you here phase to uh, degrees to radians conversion. Our phase is at 180 degree. Now radians is equal to pi by 180 into whatever that is phase, that is 180 or 90 degree. So we'll multiply with that. So finally we will get in resultant is with a radians. Suppose what I have here, pi by 180 into 180, 180 180 cancel, that remaining is pi is nothing but a 3.141592635 radians.